one of the things that happens when you leave it till like 35 seconds before you press play for a live video is that when I went live, I had one concurrent viewer, meaning I was the only one watching myself, making the whole hello to everyone thing a little bit less useful. If you are joining this later, or you are live like Leo and Alicia are, I'm going to be taking a brief look today at using conversion graphs to turn things into other things, and how we're going to do that. It's not going to be long, but it's going to hopefully make sense. I will do my best to make sense of it for you. I hope you're all well. Let's get straight into it. So, briefly, good morning to Leo, Alicia and Toto, and anyone else who joins us later. I am going to be today converting things into other things, and to do so, I'm going to go straight to my conversion tables. You'll see I've got 3 of them to work with today. So the first one we're looking at is a normal converting kilometers per hour to miles per hour. Now you will notice I've already pre-made this graph. You may notice that there is a key point here, and that's here. The standard conversion is that 80 kilometers per hour is the same as 50 miles per hour. And obviously it makes sense that naught is the same as naught. And this line allows us to convert whatever we get to each other. Now, how conversion graphs work? You will have a thing along the bottom and a thing up the side, which will tell you what you're converting. So this one is converting kilometers per hour to miles per hour, or the other way round. What you then need to do, and I'm going to use a nice thin highlighter here to try and help me. When you want to convert, what you need to do is look at what the question's asking you. So for example, I want to know what 60 miles per hour is in kilometers per hour. Now, we can do it with a series of calculations on a calculator, but the graph is useful because what it does is it allows us to directly read across from the 60 all the way along this line. As soon as we meet the line, we read down. Now, the problem is with highlighter is it's slightly different, so it's less easy to use. So what I'm going to do is, instead of that, I'm going to use normal pencil, but I'm going to go yellow and we'll see what happens. It's not really thick enough, is it? Probably something like that. That's better. Here we go, all the way down there. And we get the answer 95 kilometers per hour. And I don't like the P, I prefer to use kilometers / hours for kilometers per hour. But we can see how they convert to each other. Now this method can work the other way too. So if we have a question of, well, what about 40 kilometers per hour in miles per hour? We can work it out the other way. We go to where the thing we've got 40, make it a nice big fat thing, and read up to the line. We then read across, and conversion graphs always work like this. So you have an amount we want, and to convert it you go to the line. Hello Harriet, hello Patrick. Once you get to the line, you read across to the other table, and this tells us it's 25 miles per hour. Okay, so to use conversion graphs, now there's various different ways this might be used. This one is converting to speeds, to different speeds. The reason being, in France and Europe, they use kilometers per hour, and you'll see if you ever go across there, it looks like the speed signs are much faster, but they're not. It's because they use kilometers per hour, and if you're used to driving in your car in miles per hour, you need to know how they convert to each other. Now, most of your speedometers have both of them on there, but it's useful to know how they relate to each other. Especially, imagine you were coming over here from France, and you wanted to know we have a speed limit on many of our faster roads of 70 miles an hour. So it's quite useful to know what 70 miles per hour is. If I read across, I'm trying to use as straight a line as I can. I would normally use a ruler if I was doing this in class, and read down. So you can see, actually, if they've got the same speed limit as in Britain, 70 miles an hour is actually about 112. Now you'll notice when it's approximate, I use a wavy equals. This is to make it clearer that this is approximately equal to, not exact, because I can't read off exactly what it is, but it's approximately. And you'll see I put arrows on here to show where I've gone from. I went from 70, went along to the line, and then went read down to see where I got to. Okay, and you can use this to work out any conversions. Okay, hopefully that makes sense. I'm going to do 3 conversions now on the next slide. This one is how we turn kilograms into pounds. This is because some people will like to measure in kilograms and some people like to measure in pounds. And we can measure different ways. You can also, I'm going to try and show you how we can work out what 90, now pounds, some people get confused. Why is pounds LB? And it's to do with, I believe, the word Libra. I will just look it up while you can see my face. I believe it's to do with, I looked this up before, I think it's to do with Libra being scales or balance, and LB being short for Libra, but I'm just going to check. Why do we use LB? Abbreviation LB, the form LB is an abbreviation of the Latin word Libra, which could mean a pound, itself a shortened form of the full expression Libra Pondo, which is pound weight. See, I do know some facts. I was right. Libra Pondo is is what we use as a pound. So we now use, instead of pounds, we want to know what 90 pounds is in kilograms. I also want to know what 25 kilograms is in pounds, and how would I go about doing 220 pounds? Because this is something you can do as well. 220, that's a target weight of mine at the moment. I'm trying to get down to it, but I've been very bad the last few weeks. Since I had a baby, it's difficult to have a baby and think about what you're eating, but I'm hoping to start running a bit more and get myself a bit more physically fit and healthy. So, first of all, let's do the 90 pounds one. So, a good way of doing it is with a straight line. Let's see if it will let us. Oh, not quite right, but it's nearly there. I don't know if it's going to let me move it over exactly or if it's going to break it, but that's not too bad, is it? That goes up to there, and we want to then read across from this point here. Not quite straight at the end, and I want to make it straight so that people don't write in and complain that your lines aren't very straight. We would like to complain and have you fired from line drawing. Okay, this says to me it's about 42 kilograms. However, I'm now going to change from an arrow to an approximately equal sign. If you take nothing else from today, that's quite a useful way of doing it, and the approximately equal sign shows you that it's about the same. 25 grams, I'm going to go the other way. I'm going to use a different colour so that it's easier to see which question applies to which one. And because of that, I'm going to mark this one as being the green one. 25 kilograms is going this way. Doo-doop. You have to make the doo-doop noise. And then down. Doo-boop. And is approximately equal to 54 pounds. But I did say to you that I was going to show you how you could use it for a number that isn't even on the graph. How is that even possible? We're going to use blue. How are we going to do 220? I'm going to first of all make it slightly thicker so it shows up on the display nicely. How on earth can I do 220 pounds is approximately equal to in kilograms? This is what I'm going to do. I'm going to first of all get my rubber and rub out the purple. and I'm going to put this, and what we're going to do is we're going to say, well, I can't see 220. 220 is over here somewhere. But what I can do is find 110. Can you all see why I would do 110? It's because it's half. So if I find out what half is or what a tenth is, I can work it out. Because if I go and say, well, what's 110? That's not the straightest line in the world, is it? 110. Beep, beep. Let's do ink to shape and see if it makes it nice and neat. There we go. It's much neater. Now that gives us a 50. So once we know that 110 is approximately 50, we can times by 2 to go the other way. So that must be 100. So what I've done here is I've used my graph, but I didn't have the exact number I needed on the graph. I had to make do with a different number and then double it. So hopefully that makes sense to what we're saying. 25 be 55. So 220. The reason it's not 55, Patrick, is because what I had to do is I had to do 110, which was half of it, and that gave me 50. So I had to double it to see what 220, because I need 2 lots of 110 to make 220. That's why I've got 100. Hopefully that makes sense. And people are asking, good morning, Ellis, nice to see you. Hopefully that makes sense to Harriet as well. I hope you're understanding that. And Toto, hope that makes sense to you. And Leo, I hope that makes sense. So we can sometimes work out calculations that aren't even on there. For example, how could I do 160? New colour. 106. Oopsie. Let's not do 160. Let's do 80 kilos. 80 isn't on there, but never fear, because what I could do 40, but I've got a line on 40 at the moment, and it's a bit messy. So I'm going to do 20. I can use my chart to do one that I know mathematically goes into it. 20 goes to 44. And so that allows me to go, well, that's times 4, so that's times 4. As long as you write down your calculations, 4 lots of 44 is 4 40s are 160 plus 16 is 176. 176. 160 plus 16 is 176. So we've got 80, 20 goes to 80, and 44 goes to 176. So you can even use conversion graphs when you haven't got them. Now, I've shown you weight and I've shown you speed. The other one I like to do is currency, but I don't know if I could get a currency. So here's another measurement one. Currency graphs are really good, but the only one I could find was converting francs into pounds when I was trying to do it nice and quickly. And because francs don't exist anymore, when I was a little boy or girl, I think I was a little boy. When I was a little boy, it was called francs, but we now have a new thing called euros. And you can use conversions like that, like euros, to help you as well. But this one works the same way. How can we turn feet into meters? Now, why would this be useful? Well, funny enough, you should ask. What have we got with social distancing right now? Social distancing says we must stay 2 meters apart. And it's been really annoying me. Really annoying me. As a maths teacher, it shouldn't annoy me this much, but it really annoys me because when I go into the shops, it says to me, it says on the thing, 2 meters or 6 foot apart. And I sit there and I'm like, because look, 2 meters is actually nearer to 7. 2 meters is approximately 7 feet. And it really annoys me. In fact, I can tell you factually, 6 feet is 1.8 meters. It's less if you do 6 feet than it is if you do 2 meters. They're not saying it correctly. And I understand why, it's for simplicity. But I don't like it when people get maths wrong. I don't like it. They should be saying 6.3 recurring feet. Or just stick to 6 foot or stick to 7 feet. Because 6 foot is not 2 meters. But there you go, that's just my little aside to people. What we can do is the same idea as we had before. What would 7 metres be? You can pause the video and see if you can work it out. What would 18 feet be? Pause the video and work it out. And just like before, what about 20 metres? Pause the video and work it out. I'm now going to show you, so if you haven't paused the video, that's your own fault. 7 metres. And then... So we've got our arrows to show which direction we read from, and I think that's about 23. So 7 metres is about 23 feet. 18 feet. We're going to go the other way. We're going to use blue for 18, and we're going to go... Put a little arrow to show where we've gone. And it's about 5.6 metres. And then 20 metres. Oh, we can't fit 20 metres on. But we can do 10. So we can use the yellow one to go from 10. That's the worst line you've ever seen in your life. That's even worse. I need a steadier hand. Like that. And then about 33 feet. That's not right, sir. 10 metres is about 33 feet. Therefore, we rub out, because we want the 20 metres. So when we're trying to do the 20, it's not like that. We have to double our calculations, and we get about 66. Remember, this is an estimation, not exact. Okay, I like your calculations there. Nice to see you, Alvy. Okay, hopefully you're all clear on how this conversion graph goes. So what we've done, we've spent 15 minutes working on conversion graph. Now, in the link below the video, you should find a few more questions with some answers on how you can use conversion graphs, and you can use that to practice. Remember, practice makes permanent. It's all well and good following Mr. Harris and his silly, zany chit-chatting and arms waving all over the place, but the next thing to do is go away and practice the skill. So, that is conversion graphs. I hope it's been useful for you. I hope you've learned something. If you have, consider liking the video, consider letting other people know, and do the practice makes permanent bit. Because if you don't do that, then how are you going to practice? How are you going to make sure you know it? I am going to go off now and go and see my baby and get some things done. I'm here again at 1 o'clock where I'm doing a lesson on something. I'm doing a lesson on enlargement for secondary school pupils. If you want to join that, you can. If not, I will see you again for the either transition lesson tomorrow, maths and sport, or Friday when I've got the number quest game. So, look after yourselves, take care. I've been Mr. Harris, you haven't. See ya!